Hi, I'm Bob. Thank you for watching the videos and working on the exercises with me in the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We have now reached Chapter 16, which deals with uncertainty. Today, we will address the problems in the first section of assessing risk. Here's exercise 1.1. In a neighborhood with 1,000 houses, 5 catch fire, 7 are damaged by high winds, and the rest are unharmed during a 1-year period. What is the probability that a fire or high winds damage the house? We use the frequency to calculate the probability of houses being damaged by a fire or high winds. Let's solve exercise 1.2. Asa buys a painting. With a 20% probability, the artist will become famous, and the painting will be worth $1,000. With a 10% probability, a fire will destroy the painting so that it becomes worthless. If the painting is not destroyed and the artist does not become famous, it will be worth $500. What is the expected value of the painting? The expected value of the painting is the weighted average of the values of each possible outcome, where the weights are the probability of each outcome. There were 3 possible outcomes of the painting. Let's answer exercise 1.3. By next year, your stock has a 25% chance of being worth $400 and a 75% probability of being worth $200. What are the expected value and the variance? The expected value of the stock is the weighted average of the values of each possible outcomes, where the weights are the probability of each outcome. It equals the sum of the product of the probability and the value of each outcome. The variance of the expected value is the weighted average of the squares of the differences between the observed outcome and the expected value, where the weights are the probability of each outcome. The variance is a measure of the spread of the probability distribution. Let's go to exercise 1.4. The EZ Construction Company is offered a $20,000 contract to build a new deck for a house. The company's profit, if it does not have to sink piers down to bedrock, will be $4,000. However, if it has to sink the piers, it will lose $1,000. The probability it has to put in the piers is 25%. What is the expected value of this contract? Now, EZ learns that it can obtain a seismic study of the property that would specify whether piers have to be sunk before EZ must accept or reject this contract. By how much would the seismic study increase EZ's expected value? What is the most that it will pay for such a study? The expected value is the weighted average of the values of each possible outcome, where the weights are the probability of each outcome. It is $2,750. Suppose the study gives the company perfect information about whether it has to sink the piers to bedrock. The company will not accept the contract if it has to sink piers to bedrock. The value of this possible outcome is 0 instead of minus 1,000. The expected value becomes $3,000. The gain from the study is $250. In other words, the study increases the expected value by $250. That is the maximum amount the company is willing to pay for the study. Let's go to exercise 1.5. What is the difference between an individual gambling at a casino and gambling by buying a stock? What is the difference for society? For an individual, both gambling at a casino and buying a stock are risks with different possible outcomes. In the long run, the expected value of gambling at a casino is negative, while the expected value of purchasing a stock may be positive. In my view, the risk of gambling at a casino is higher than buying a stock since the former has a larger variance than the latter. For society, the stock market has a more beneficial effect on firms' development and economic growth than the casino. Let's address exercise 1.6. To discourage people from breaking the traffic laws, society can increase the probability that someone exceeding the speed limit will be caught and punished. Or it can increase the size of the fine for speeding. Explain why either method can be used to discourage speeding. Which approach is a government likely to prefer and why? Both methods decrease the expected value of speeding. Suppose the driver gets a value or pressure of V if he speeds and does not get caught. He pays a fine of minus C if he gets caught. The probability of being caught is theta. His expected value of speeding is the weighted average of the values, where the weights are the probability of the possible outcomes. The first method increases the probability of being caught, theta, and therefore the expected value will fall. The second method increases the size of the fine, C. It also reduces the expected value of speeding. A reduced expected value of speeding discourages speeding. The government is likely to prefer the second approach because it does not increase enforcement efforts, while the first approach needs more police and prosecution. Let's go to exercise 1.7. Suppose that most people will not speed if the expected fine is at least $500. The actual fine for speeding is $800. How high must the probability of being caught and convicted be to discourage speeding? Assume that the probability of being caught and convicted is theta. The expected fine for speeding equals the probability of being caught and convicted times the actual fine for speeding. We obtain the probability of 62.5%. Let's solve exercise 1.8. A drug development company develops a new antiviral medication. It applies for a patent and for Federal Drug Administration approval to sell it. The firm estimates that the patent application has a 60% chance of success and that FDA approval has a probability of 50%. The firm believes these events are independent. If both applications are successful, the drug can be sold to a major drug producer for $10 million. If FDA approval is obtained, but the patent application is unsuccessful, the drug can be sold for $4 million. If the drug is not approved by the FDA, it is worth nothing. What are the expected value and variance of this drug? We tackle the problem in 3 steps. In the first step, we compute the probability of each possible outcome. Since the 2 applications are independent, we can easily calculate the probabilities. The first outcome is that both applications are successful. The probability is 30%. The second possible outcome is that the FDA application is successful, but the patent application is unsuccessful. The probability of this outcome is 20%. The third possible outcome is for other situations, including the FDA application being unsuccessful, but the patent application being successful, and both applications being unsuccessful. The probability is 50%. In the second step, we calculate the expected value. It is the weighted average of the values of each possible outcome, where the weights are the probability of each outcome. In the third step, we calculate the variance, which is the weighted average of the squared distances between the actual and expected values. Thank you very much for watching this video and solving the exercises with me today. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.